Hello everyone, this is Dnyaneshwar Sanap, working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In this video lecture, we will discuss about the molecular orbital energy level diagram for hydrogen chloride molecule, that is HCl molecule. Let us see one by one. Basically, HCl molecule is formed by the combination of hydrogen atom and chlorine atom together. Before start the actual drawing of molecular orbital energy level diagram, we have to first of all understand the electronic configuration for the each atom which combine during the formation of HCl molecule. Let us see the electronic configuration for the hydrogen atom. The electronic configuration for the hydrogen atom is 1s2 1. Similarly, the electronic configuration for the chlorine is 1s2 2, 2s2 2, 2p6, 3s2 2 and 3p5. There are three shells in which the electron is distributed in the chlorine atom. The first shell contains 2 electrons, second shell, that is 2s and 2p orbital shell, having 8 electrons, and third shell having 7 electrons in its valence shell. Let us write this electronic configuration for each atom in the tabulated form one by one. For hydrogen, 1s2 1, and for chlorine, 3s2 2 and 3p5 for the valence shell. Now let us start to draw the actual molecular orbital energy level diagram for HCl molecule. For writing the HCl molecular orbital energy level diagram, we have to write the atomic orbital in the increasing order of energy for each atom one by one. On the left hand side, we have to write the less electronegative atomic orbitals, and on the right hand side, we have to write the more electronegative atomic orbitals. That's why we write at the left hand side hydrogen 1s valence shell atomic orbital, and right hand side we have to write the more electronegative atomic orbitals at the lower energy with respect to the less electronegative atom. In this case, basically, out of this 4 atomic orbital in the valence shell of an chlorine atom, we write here only one atomic orbital, that is 3pz. We can write here 3py, 3px, any one of them, because when we form the HCl molecule, that time the axis of bond formation at this particular axis, and that's why we write it here now. We did not write here a remaining orbital because this orbital having lower in energy and different symmetry with the joining of axis during the formation of HCl bond. That's why we write here only one atomic orbitals for the bond formation. When these two atomic orbital combines together, they form the 2 molecular orbital. Out of these 2 molecular orbital, one is lower in energy and one is higher in energy. The lower energy molecular orbital called as bonding molecular orbital, and it denoted by using the symbol sigma sp, and higher energy antibonding molecular orbital is denoted by the sigma star sp. The lower energy bonding molecular orbital called as stabilizing bonding molecular orbital, and the whatever molecular orbital is formed is stabilize the formation of HCl bond. Whatever higher energy molecular orbital with respect to the atomic orbital is called as destabilizing orbital, or this orbital destabilize the formation of bonding between the HCl molecule. The next important point is filling of electron in molecular orbitals. Basically, electron filling in the molecular orbital is based on the 2 principles. The first one is Avhad principle and second one is Hund's rule of maximum multiplicity. Let us see how this electron is filled in the molecular orbital. The first electron goes to the lower energy bonding molecular orbital. Similarly, second electron also comes to the bonding molecular orbital, because bonding molecular orbital, which is lower in energy, having capacity to retain the 2 electron in itself. There is only 2 electron in bonding molecular orbital and there is no electron in the antibonding molecular orbital. From this molecular orbital energy level diagram, we can write easily the electronic configuration for the HCl molecular orbitals in the increasing order of manner. Let us write the electronic configuration for the HCl molecular orbital. First of all, we have to write the K for the first shell of an chlorine atom, because this electron does not participate in the bonding. Similarly, we have to write the L, because second shell having 8 electron of chlorine atom and it does not participate in the bonding. That's why we have to write here L. And the third shell in which the 1 electron is participate in the bonding. That's why we did not write here any notation for the shell. And after writing the K and L, which is not participated electron from the both atomic orbital, we have to write the electron in the bonding molecular orbital, that is sigma sp is 2, and that's why we write here the sigma sp2. And the electronic configuration of HCl molecule is Kl, then sigma sp2. The next important point is calculation of energy evolved during the formation of HCl molecule. Basically, energy evolved during the formation of any kind of molecule is calculated by using the formula number of electron in bonding molecular orbital into minus beta plus number of electron in anti-bonding molecular orbital into plus beta. There is only 2 electron which is present in the bonding molecular orbital, and that's why we write this figure in the formula. We get the equation 2 into minus beta plus 0 into plus beta. After solving this equation, we get the values of minus 2 beta, that is the stabilization energy or the energy evolved during the formation of HCl molecule. The next important point is calculation of bond order. Basically, bond order is calculated by using the formula number of electron in the bonding molecular orbital minus number of electron in the anti-bonding molecular orbital divided by 2. After putting the value in the equation and after solving it, we get the value of 1. That means there is formation of one bond between the hydrogen and chlorine atom respectively. The next important point is stability. As the energy wall is minus 2 beta and the bond order is 1, it indicates that there is formation of bond between the hydrogen and chlorine atom, and that's why the HCl molecule is formed easily and stable one. The next important property is magnetic property. Basically, there is only pairing of electron, and that's why this molecule is diamagnetic in nature. Thank you. Thank you for watching.